Do you have problems balancing chemical equations? Well, let me help you. Maybe you can find something useful here. We have about 5 equations which we need to balance. Well, we are forgetting the state symbols. Our main interest is to balance them. Okay, so the first one says ion reacting with sulfuric acid, which is, you can just say hydrogen sulfate because we don't know the state symbols, giving us ion 2 sulfate and hydrogen, which is like H2. How do we balance this chemical equation? First of all, we have the right side, which is this side. Now I'm saying the right side of the equation. If it's you, this is your left side, and this one becomes your right side. Right? So you're going to take in reference to yourself, not to the equation. So this is your left, so your left, and that is your right. Now, count how many ion atoms do you have on the left side? 1. How many do you have on the right side? 2. So put a 2 there. This means ion is balanced, right? All right. Next, how many hydrogen do you have this side? 2. And how many do you have this side? 2. So we don't have to temper that one. Okay. How many sulfates do you have? I've got 3 sulfates here, and I've got 1 sulfate. How many oxygens do you have? You've got 12, and here I've got 4. So if I need to have 3 here and to have 12 here, don't you think I can just put a 3 here, such that when I multiply 3 and 1 here, I get 3 sulfur. 3 times 4 there, I get 12 oxygen. But this 3 which I've put here, it has killed the hydrogen. Hydrogen is now 6. That means I can put a 3 there, so that even hydrogen is 6. So if you've seen how I've started with the ones that I can easily balance. Then those that are already balanced, I don't have to temper them. I need to follow those that are not yet balanced. Is it clear, right? We are here. This is methane reacting with oxygen. This is in a combustion form to give us carbon dioxide and water, H2O, which is hydrogen oxide. First of all, how many carbon atoms are here? 1, and there 1. Don't temper. How many hydrogen are here? 4. How many do you have here? I've got 4. Sorry, 2. So I put a 2 there, so that the hydrogen is 4, and even here hydrogen is 4. How many oxygens do you have here? 2. But how many do you have this side? I've got 2 here, 2, and this 2 is multiplying that 2 there, so there are 4. So if I put a 2 here, oxygen is also balancing. You've seen that these things are easy, right? Very easy. Now this one, we have silver iodide plus sodium sulfite and silver sulfite plus sodium iodide. So how do we balance? How many silver do we have this side? 1. How many are here? 2. I'll put a 2 here. So that silver is balanced. Iodine now has become 2 as well because of the presence of these 2 here. Are we together? So that 2 has changed everything. It is going to affect everything. So even iodine now is 2. But here iodine is 1. So we need to do something about iodine, alright, as early as possible. So if I put a 2 in front of sodium iodide, iodine balances, but sodium, does it balance? Well, 2 times sodium, we've got 2 sodium. Even here we've got 2 sodium. Sulfur is balanced, so the equation is balanced. You've seen how this is, huh? Then next we've got ammonia reacting with oxygen to give us nitrogen monoxide and hydrogen oxide. Alright, so how do we balance this one? So let's go. Now this is why we need to be very, very careful. When we look at the equation, it looks simple, but, well, how many nitrogen are here? 1. And how many are here? 1. Okay, so we don't have to temper it. How many hydrogens are here? 3. And how many are here? 2. So you know what the problem is? Here hydrogen is 2, and here is 3. How many is oxygen? Here oxygen is 2, even here is 1 and 2, which is 2. So the only element which is not balanced here is hydrogen. So we need to find means and ways of balancing what? Hydrogen. So if hydrogen here is 3 and here is 2, I need to look for, because of this and because of this, you can swap them. Okay, you can swap these multiples, they become scalars. So this 2 can come here and that 3 can go there. I'm just getting there, so don't I'm showing you step by step. Now that hydrogen is, remember that nitrogen and oxygen, they were balanced. Now let's also balance hydrogen, which we've now balanced. But the presence of 2 here, it has affected nitrogen. It has become 2. Are we there, right? It has become what? 2. Nitrogen has become 2. So if I put a 2 here, nitrogen will be balanced, right? Yes. Okay. But this 2 has also affected what? Oxygen. Even this 3 here has affected what? Oxygen. Oxygen has become how many now? Here oxygen has become 2, and the 3 there, it has become 5. Are we there, right? And here oxygen is what? 2. Now this is why I want you to pay particular attention. Here oxygen is 2, but here oxygen is 5. Do you remember what we did when we had hydrogen 2 here and hydrogen 3 there? What do we do? We swapped them, right? So let's swap this 5 to come here. Now remember the 5 is a combination of everything here. So we are going to say this 2 is going to multiply everything here. So when this 2 multiplies everything here, what do we get now? Okay, we ended up getting 4 here and 6 there. You see how beautiful it is, right? It's very easy. That's why you just have to be thinking in that way. Now look, how have everything been balanced? Nitrogen is how many? 4. How many is hydrogen here? 12. That means we need to put a 4 here, but nitrogen is 4 and hydrogen is 12. It's balanced. So you can interchange factors of 2 elements so that you can balance them. The last one is iron oxide, which is iron oxide, and we have carbon monoxide giving us iron and giving us carbon dioxide. So how do we balance this one? Well, let's go and count how many iron atoms are there. 1, 1. Don't tamper with it. Let's count how many carbon atoms are there. We have 1 here and we've got 1 there. So then don't tamper with it. How many oxygen atoms do we have here? We've got 3 here and we've got 2 there. Oh, sorry, we've got 4. This one and this one there. We have 4. And here we only have what? 2 oxygen atoms. I'm interested in the oxygen atoms. There are 2. Well, from there, I think things are even sweeter now, isn't it? All right. So if I need a 4 this side, because this is where they are few, right? If I need a 4 of oxygen, I need to put a 2 here, therefore, so that I can have 4 oxygen, but carbon will also be disturbed. Carbon will be what? Will be disturbed. So if I put a 2 here, carbon becomes what? Disturbed. Now check it out. You can try numbers at your own free time. You are well and okay, you are okay. You can try numbers, there is no problem. So when you look at here, we don't want to temper this element here. We also don't want to temper that element. We leave them the way they are. And the only way we can do this, when you look at this equation, is we can temper this one and this one. These are the one that we can temper. This one is easy. They have carbon and oxygen, so we can easily temper them at least. Alright? Even this one has got iron, but at least one does not have oxygen. But these two, they have, both of them, they have oxygen, so we can easily manipulate them. Iron and iron oxide, which is the 3-1, we can't, because This one doesn't have oxygen, but this one has oxygen. So those we can leave them as exceptions. I don't know if you're getting my concept, but these with oxygens and they're all having carbons, we can manipulate them. Okay, so I've got 1 here and I've got 2 there. So if I put 3 here and I put 3 here, what do we get? We get 3 carbons and we also get 3 carbons. Balance, right? We get 3 oxygen and here we get 6 oxygens. But there's also another oxygen here giving us 6. So this is another technique when you have got 2 compounds having something in common and the other compound they have in common, but the other one is missing something which is also supposed to be in common. So that's another trick that you can do there. All right, guys, you can go online, search for equations, and well, get a skill. This is a skill which you need. It's like solving mathematics. You need a skill. This is how these equations are.